Hello, my name is Rich Howard, owner of Architectural Builders Supply. This video is to bring you a closer look at the Stanley. This is their part number BB852. That part number that's right here is BB852. It's an application G. It happens to be 5x6. They have these as left hand. I'm not aware that these are handed at all. US prime, and there's a reference to a drawing number here as well, which we'll take a closer look at. So this is a unusual hinge. However, unusual hinge and my client base generally go together. I have it removed from the box, and here's what it looks like when it comes out of the box. Now, an application G is a half mortise, so it's going to look it's going to actually look like this, is what it will. Half mortise. Give me a second here. Yeah, give me a second here. Yeah, so we're really showing it like this, is what we're actually showing it like. Okay, that's what that hinge is going to look like. This is what's called a half mortise triple weight concealed ball bearing prison hinge, and it's in their detention hardware. So half mortise, first of all, that's going to mean the terms full surface, half mortise, full mortise. These are terms that relate to how the hinge is actually manufactured, and specifically how the hinge leaves are bent in the manufacturing process, the swag on the hinge leaf. So a full mortise hinge will have a different bend on the individual leaves when compared to a full surface hinge. A full surface hinge won't have any bend because that hinge needs to lay flat and not be bent. But a half mortise hinge, those hinge leaves need to be bent because when the door is closed, the edge of the door and the frame, when those leaves are brought parallel, there's meant to be just a small gap there. Now you can take variations of a half mortise, of a full surface or a half surface, and do a full surface or a full mortise. You can do variations of a full surface or a full mortise hinge, and do a half surface or a half mortise. This happens to be a half mortise, which means one leaf is going to be installed down to the door as a normal hinge would be. And what a half mortise hinge is it means that the hinge leaf is normally mounted to the door in its standard application, which means the leaf that goes to the door is mortised. So when the term half is used, that is referring to the leaf that attaches to the door. So if we say half, start thinking leaf to the door. Half mortise means that the leaf to the door is mortised, just like a normal full mortise hinge would be. If we say half surface, half says think leaf to the door, and then we say surface, the leaf that goes to the door is surface mounted. Okay. Now, this hinge, being half mortise, means that the leaf that goes to the frame is not the standard leaf. The leaf that goes to the door is the standard leaf when we're using full mortise as our benchmark. So in this application, when I have the hinge in this orientation, this is the door. Okay? This area here is the frame. When we have a half mortise, the leaf that goes to the door is mortised like a normal hinge would go to the edge of the door. The other leaf is opposite. It's surface mounted. It's a hybrid of full surface and half mortise. It's a hybrid of those two. Half surface or half mortise means it's half full surface and half full mortise. The term always applies to the door leaf. So a half mortise means the leaf that goes to the door, let's do it like this. is going to be its normal leaf. So in this application, this is the door. My arm is the door. That means that the frame is in here, which means that the leaf that goes to the frame is the surface leaf. Okay? So you can surface to the door and mortise to the frame, or you can surface to the frame and mortise to the door. Surface to the frame and mortise to the door is half surface. Surface to the frame and mortise to the door is half mortise. Okay? So this is what it looks like in the closed position when our door is here. I can take this. Okay, here's our door as a left hand. Okay, I can turn that around, make it a right hand, or reverse. I see no reason why you can't do any of that. You've got some sort of evidence of assembly here. Okay, I'm sure there's nothing serviceable in this at all. This is an epic hinge in the sense of it's made of steel. It is it's about 5.1 pound is what this weighs. It weighs over 5 pounds. There are no fasteners with this. We'll talk about that in a moment. The height of the leaf is 5 inch, maybe just a hair shy, it looks like. No, it's 5 inch. Now, where they come up with 6 inch, I really don't know where that's coming from. Obviously, when we open that hinge up, it's measuring 6 inch. That's really not an important dimension that I'm aware of, but you do want to know the height of everything. The other dimension that we'll give is, let's give a couple of dimensions. And there is a drawing that I have, the leaf thickness. The leaf thickness that's going to go to the frame, 0.383. 0.383. The door should be the same. It's a little bit thinner, 0.375. So these leaves are nominally 3/8 of an inch thick. Okay. This is going to be intended for a staggering amount of weight, is what this is going to carry. And we do make an attempt and an effort to keep odd hinges here because we routinely get calls. I have a 1,000-pound gate and I'm looking for some hinges that are in stock. And for as wild as that sentence is to say, we hear that with some frequency. This is it's a BB852 is what this hinge is. Then it's an application G, which means half mortise, but a specific variant of half mortise where the leaf is such that the frame and the door are drawn a certain a relationship to each other, and I'll show you that in the drawing. This happens to be USP, which just means prime coat. I would highly doubt that any other finish is going to be offered in this. I would really doubt that because this is meant to be welded in place. Okay, so let's do this. Let's switch. Let's put this heavy hinge down. Let's switch to the screen view and let's take a look at all of the supporting information. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Here is the hinge that we are looking at. This is the cut sheet. We've taken a look at the hinge in the video already. Let's start with the cut sheet. Triple weight concealed ball bearing prison hinge. This is a BB852. Steel with welded pin, phosphated and prime coated for painting. For lead line doors to x-ray rooms and extremely heavy doors and gates. Let me show you an application of where we recently used this. Our clients had ordered some, I believe they were FBB163s, just typical Stanley half-surface hinges. And they were wholly incorrect for the application in terms of the weight of what they were building. And I recommended to the client the BB852, which is what they went with. I also recommended that the client consider a concealed hinge if they were able to fit the hinge in the depth of what they were building, because it would handle the weight. But this was the type of application, and they had to modify the hinge so that it fit on the face of this probably 2-inch tube. But that's where this all started. They were building something quite custom and quite heavy. And that's where it started. So for hinged cell front doors and graded steel doors of penitentiaries, jails, and reformatories. Made of triple weight steel, capable of carrying doors up to 2,000 pounds, based on a 3070 with 3 hinges. Now that is the ultimate weight of a 3070 door. That is obscene in terms of something so heavy. This hinge is meant for that. When they say triple weight, I'm going to think that means a standard weight hinge is about 134 thousandths. Or in this case, it'd be 140 thousandths on a 5 inch. Triple weight would be about 420 thousandths if we were tripling a standard weight. And these were closer to 0.38, if you recall, about 3/8 of an inch thick. Each of the 2 concealed hardened steel races contain 16 3/16 hardened and ground steel balls, which are assembled within a jacket. Provision has been made in the barrel for the hinge of the hinge for forced lubrication. If necessary, lubrication is necessary. That's going to be that access hole that we showed earlier, that service hole. Typically made, not swagged, no holes, for application A for full surface, or application C for full mortise, or the other applications. Rolled knuckles are welded and machined, and they are indeed. When they've bent that hinge leaf, they've bent that steel. They've gone in and they've re-welded all of that. And that evidence is right here. That's all been welded. Pin is solid one-piece steel welded at both ends, making pin removal impossible. 2 concealed bearing assemblies, hardened raceways, hardened and ground balls. 3/16, total of 16 of them. The key here is 2,000 pounds. That's the key. The key is you're going to have to weld this material, or it's going to have to be welded. It's not been tested to be drilled and tapped. The issue, though, is for lead line doors to X-ray rooms, you're probably not welding this to a lead line steel door. I would imagine you'd want to keep that heat away from lead. But how you're going to go about installing the material obviously remains to be designed, but nonetheless. So let's take a look at the application. Let's go first to the application G that we are working on here. This is it right here. It's a half mortise. And there's an F and a G application. To my eyes, it looks like the F application is going to give you that 1/8 of an inch. If you've designed your gate for an 1/8 of an, or whatever you're hanging for, an 1/8 of an inch margin, you'll want the F style. We'll look at the drawing and we'll see if they tell us anything about this. The bottom line, however, is you can see how, if you really study the drawing, how the offset on the F is not offset, whereas on the G application, it is offset. So my understanding of the fact that they've bent this leaf biased in this direction, you're going to have less than an 1/8 of an inch here. Marginally less. Face of the door to the center line of the vertical axis of pivoting, 1 1/8. Okay. We're also saying that that is the case on the channel iron frame as well, which means that this would be a flush. There would be no inset. The door is not inset into the frame at all. So you're going to line the face of the door up with the face of the frame. Variations of half mortise or half surface types can be obtained by further bumping or swagging of mortise leaf to accommodate any required construction. And they do want you to specify hand when ordering. So I don't see necessarily why that's going to be the case when you are ordering this hinge. The manufacturer did not ask me for the hand when they produced the order. They did either assume or just insert left hand, but I don't see any reason why I couldn't turn this hinge over. So at this time, I'm going to say handing is not required. And it also appears to me that C, D, and E applications are not handed. A application appears to not be handed, as well as the B application. So I don't see why they're saying specify handing when ordering. Now, it's always the right idea to specify the hand when you're ordering anything. So should something come up in the future that makes me realize, this is handed, we will amend our conversation. So that's the cut sheet. Let's take a look at this document called drawing, and the factory sent me this drawing, and I'm grateful that they did, in the sense that it did allow me a more intimate look at the components of the hinge, albeit in a language that I don't speak and in a system of measurement that I'm less familiar with. But it's awfully handy to have this information here. So that's a technical drawing from the factory on a BB852 application G. You've got your two hinge leaves here, and they literally said, okay, please approve this. I'm like, what? Well, okay, if you say this is a BB852 application G, I approve. But when we look at this, we can get the concept of what's happening here. You've got your door leaf, you've got your frame leaf, and you've got your dimensions. Even though they're in metric, you can easily take 58 millimeter and divide that by 25.4. Very simple to do that. Now, we also have our product brochures here. This is going to be a walk-through detention hardware from Stanley. And if you're looking for hinges that will hold a obscene amount of weight, this would be a good catalog to look at. We do, again, try to keep some of this really odd stuff available. And what we're seeing here are really heavy, more typical hinges that are heavyweight hinges that we would bump into, except that they'll have hospital tips and they'll have security studs installed on the leaves, and that helps, that all but eliminates being able to pull the door out of the frame when the door's in the closed position. And as you scroll through, there are variations on this. We get to our BB855. Okay, this is the 800-pound version of everything we're working on. So they call these double weight. They don't tell us, yeah, the gauge is 9/32 of an inch. So 1 divided by 32 times 9. So those hinge leaves are going to be 0.28 for 8. So I was trying to calculate in my head 9/32 of an inch. So it's just heavy on 1/4 inch. Okay. So there's the 800-pound version. Here comes our 2,000-pound BB852s. And then additional items that you're going to see in the detention arena when it comes to Stanley. Door stops that are poured into concrete. There's nothing there to pull off to get your hands on. A wall stop of the same type. Security flush pulls. Security door pull. These are going to have security fasteners, etc. Okay. Now, there is a link below this video as seen here. And I don't have... let's see if we can find something. I want to point you to where the other resources are. There's a link below this video as seen here to the manufacturer's page. And from here, you can pull up not only all of the Stanley products that we sell, even though this is not the link I'm thinking of. The link I'm thinking of is not this one either. So there are many derivatives of Stanley, half a dozen or so. Find the word manufacturers in our site somewhere and then do a find function or Control F on your keyboard for Stanley. And you're going to get to where we can find Stanley hardware. That's the one that I like. Because the 2010 Architectural Hardware Catalog is the document that I generally refer to. In this document, you are going to find the section on detention hardware. I just searched BB852, and it took me right there. So early in the catalog, they have general hinge information, and they're giving us, door weight. There's a door weight chart here, what hinge to use based on the weight. From 1,001 up to 2,000 pounds, they're saying for 1 3/4 thick or 2 inch thick, that BB852 is the last man standing. right there. So a pretty handy document in the sense that if you were to be interested in hinges in general, this would be one of the few extremely good catalogs written about hinges in general. So everything I was speaking about early on, full surface, full mortise, half surface, half mortise, all of those definitions with examples are in the first section of the catalog. So if you're an architect, a specifier, a designer, an owner, an installer, a distributor, anyone who has to deal with hinges at any part of the spectrum of the construction industry, having basic knowledge over the terminology of hinges is a good thing. In the Stanley catalog, this 2010 version, is the document that I go to because it's the format that I first became familiar with in the early, in 1990 when I first started in the industry. And you will learn quite a bit about this. Swag on the hinge leaves are defined here. This would be a full surface hinge. This would be a full mortise hinge. This would be a raised barrel hinge. Okay. So lots of information here. Let's wrap up this video on camera. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. We are actually not ready to wrap this up on camera. I have some photographs that I would like to show you of the hinge. Here's the box. In no particular order, here's the box. Application G, BB852. Showing the hinge in what would be the door closed position, and I have some additional photos showing that. What you would see when the door is closed. Well, actually, no. What would you see here? You would see nothing. This is when the door would be technically at 270 degrees. If it could, well, if it could rotate, the door would be sticking out here. You'll really never see it in that orientation. This is the leaf where the door would be right behind here. Just showing what it looks like when it's nested together. This would literally be when the door is at 270 degrees. Your frame would be here, your door would be here, and the door would be here for 180, the door would be here for 90, and then the door would be here to be closed. Okay. Showing another view of the hinge. Another view, and then three images that might make more sense. Door and frame. I've just marked those boxes so that it's obvious of how, well, it's reasonably obvious in terms of how that material is meant in relationship to each other. Okay, you can see how the door is supposed to sit. Probably would be a little bit nicer had I used a box that was thinner than this. Okay. Showing the door at 90 degree. Well, actually, no. Showing the door at 45 degree. Then showing it at 90 degree. All you got to really do is study the drawing and study the photos, and it will start to make sense. And if you follow the original rules, half mortise or half surface, we're always talking about the leaf that goes to the door. Is it surface mounted to the door for half surface, or is it surface mounted, pardon me, or is it mortise to the door as in a half mortise hinge? All right, now we have all of the information that I wanted to discuss. Let's wrap up this video on camera. Okay, it's one heck of a hinge. When it comes to very interesting hinges, we do try to keep hinges that can handle a lot of weight like this. Some of those institutional heavyweight hinges with security studs, your heavier doors, but nowhere near 2,000 pounds. We're going to keep Harmon hinges on hand, which are known as pocket door hinges. We're going to try to keep concealed hinges on hand. We're going to keep pivots that are intended for obscene weights, 1,000 pound. We intend to keep on hand, Rixson has a 3,000 pound center hung pivot. try to keep that as well. So if you, and then of course continuous hinges, the continuous hinges can handle, extremely heavy weights as well. So we try to be that source where I should have ordered this 3 months ago, and I didn't, and hopefully you have it in stock. Now when it comes to Stanley, I'm always extremely impressed with their fit and finish. Okay, most manufacturers' hinge leaves just don't swivel or move that flawlessly. The only defect on this hinge now are my fingerprints. This comes out of the box. It is nice. It is in such a condition that you have every reason to expect that the manufacturer has a very firm grasp over the manufacturing process. And while it's just a hinge and nobody really thinks about it, in my opinion, the hinge should look just as good as the door lock. And some manufacturers don't set the bar that high. Stanley does. And I prefer them because of that fit and finish. And they're also able to manufacture hinges that other people I have found take a pass on. We can't make that hinge. So let's ask Stanley. Sure, they can do it. They can't do everything, every conceivable item, but they do stuff that other people won't. And that's why we send work their way in these instances. Any questions on the BB852 detention style hinge or any other Stanley product, please feel free to reach out to us. And thank you very much. Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.